Okay, for the question number 4, the heat pump received heat from the lake has average winter surface of 6 degrees Celsius, supply heat into the home average at 27 degrees Celsius. Given that the specific heat of a warm water is, the water is Cp equal to 4.1 for A. So given that this is given by the question, 4.18 kilojoule per kilogram dot Kelvin. Okay, now the question asks you, if the house loses heat to the atmosphere at 65 kilojoule per hour, what determine the minimum power supply to the heat pump? Okay, right. So coefficient of performance for the heat pump maximum is 1 minus TL over TH. Okay, then one minus 6 plus 273 plus 27 plus 273. Okay, equals to 14.29. So in other words, this is from the TL. This is the heat pump. This is the working. Okay, so to the TH. So QL, QH dot. Okay, so coefficient of performance for this one is 14.29. So the minimum power input here, W dot in, so W net in equivalent to QH dot over COP maximum. So QH is what? Given by the question, it's 65,000 kilojoule. So 65,000 kilojoule per hour. So 65,000 divided by, because we want it in watt, so by 3,600, okay, over 14.29. So we got the answer of 1.263. So 1.264 kilowatt. So what is the rate of heat absorbed from the lake? Okay, so this one is A. So what about B? So we know that W in equivalents to QL dot QH dot minus QL dot. Therefore, QL dot equals to double QH dot minus W dot. Okay, and then equivalence to QH dot is what? This one. So divide by 3,600. So 18.05. So 18.05 minus 1.264. So because it's kilowatt, this one also kilowatt, we can simply minus this one. So minus 1.264. So 16.79 kilowatt. Therefore, the mass rate of the water, where the minimum mass flow rate in kilogram per second, so m dot equals to QL dot over MCP delta T. You might wonder where this one. So this is the standard equation for the QL dot equals to M dot CP delta T. If you remember that we have the same equation in lab 3, right? So 16.79 kilojoule per second or kilojoule kilowatt over CP, which is 4.18. Okay. Temperature difference is what? 10 degrees Celsius. Okay. So the temperature region is 10 degrees Celsius. So 10 degrees Celsius. 16.79 divided by 4.18 divided by 10. So 0.4 0.402 kilogram per second. So that's it for question number 4.